Welcome back to Wickerson Studios. Michael Wickerson here, and we are jumping into the Math tabs now and going into the Functions tab. Before doing that, to show you the power of that as you break it down computationally, and this is really where I think controlling curves using expression and trigonometric polynomial outputs from ChatGPT or openAI or GitHub Copilot are going to give you incredible control for manufacturing curves and surfaces in Rhino and Grasshopper. I should say that again because that is the most important thing. So please jump into this tutorial. Take a look what I have up here at the start. Going back to params, taking a look at the function editor, and then taking a look at the evaluate function node, which is in the maths. Which you want to jump into, and you can evaluate derivatives, integrals, function derivatives, functional integrals, whatever you want if you think back to math class and visualizing it. But here's what I've done. Before going in and taking a look at all these things and bringing them and activating them, which I'll do in the next video, this is a breakdown of kind of build interesting graphs visually as they come together. Now, if you're used to Touch Designer, if you're used to, just take a look at these incredible graphs that are being generated through here and influencing graphs because they're points that are solved within curves that are maybe influenced by other curves. But let's keep it simple right at the start. The graph mapper on steroids, the function editor, is absolutely amazing. So let's see what's happening. We're just solving for this, putting it through a range of -5 to 5, having 100 points, and then I'm basically putting those into a point system that I can see in Rhino. Then I would interpolate in Grasshopper, or maybe I'll just do it in Rhino. It doesn't matter. But you want to generate amazing curves. This script is amazing. So opening it up, you could just double click on it. What have I done? And look at this gorgeous influence of how you can start. This is ABC 1, 2, 3 simple to figure out, but I'll try and show how to do it. The details say what I've built is I've built a scalar function reference cosine and a scalar function reference expression. There is a hierarchy there. There's the original vector, which I can have control of and move. Now that's going to push and pull everything, and oh, maybe I can't do it once I type this in, or it's too slow. I do crash a lot on this, so I shouldn't push it. And I'm sure I just crashed. No, I didn't. I'm still moving, but look at the subtlety of the influences of those curves. So what have I done? I have simply opened the editor, and let's go back down here and show you that I input a, what did I input initially? An expression into it, which happens to be all of this expression. But maybe I can do it again without screwing it up. So let's try this again. Let's take it from the beginning. Have a function that comes in, and I think what I did was I put that through and solved for it. And what did I solve for initially? Let's take a look at what is being mapped and what is being graphed. You can use the graph map to see that and see what's happening here. But from -5 to 5, there it is. I just had to kick it off and get it answering. So what it's solving for is a cosine x function. When you go into that editor, you can add whatever functions you want to influence it, but this is the one you want. You want to drag an expression and say, what do I want to do with it? I have my grid snap on. Actually, I want to make my grid snap on, and I want my grid snap on as well here. I'm going to go into here, and I think what I wrote, and I don't really remember it, double-clicking it or right-clicking it, I can edit that. You can make it important, normal, subsidiary, or color. You can change, but I'm basically going to say, let's make that the sine of x plus a. And let that be an influence of it, and it becomes that graph. Now I want to grab that graph and make that graph, go back into it, I think hit edit. Okay, I'm okay on it. How do I get to the data again? I have to think about this. Go back to my manipulations on there. This is my slider as it moves around back and forth, and there's my control. It was a little off the screen. So I can reference this point to anywhere snapping on cosine to have an influence and solve for it at any point. Now this is a visual dream for graph mappers and people that want to think about curves and generating them. Look at that. And then it's endless. And just to keep it simple, I'm going to drag in another one, and this one I'm just going to solve for a times a, which is just going to give me double the value of a. So that's pretty simple. And then that graph, I'm probably going to connect off to this one, And I could join that at any point wherever I want to reference. So let's reference it down here. And this is how we start to generate it. Opening it up, you'll see that it's kind of like a remote controller. You can step aside over here. You can grab these as well. Now somewhere on there I should see my guide for my A value on this curve. Where's that one kicking around? Where are you? Well, if it was there, it would be a quick little slider, and I think I'd have reference to solving for A. Where's my reference to A? Okay, vector. And I do end up crashing on this when I play too much. Like now I'm influencing all those vectors. But somewhere around there, I should be able to lift and lower A up and off of that. But what a gorgeous curve to then have. Now I'm looking at it and I'm saying, well, geez, that's pretty interesting between 3 and 6 as a curve to look at. So let's close that and let's take this from 3 to 5. Well, we'll jack it up again. We'll just go here and we'll jack this one up a couple of points and we'll take it to maybe 12 in case we want to go there. And we'll just take that up to 6 where I thought it would have kind of a nice curve. And there's the curve that I can output. And let's see if that works. Take this over here, shrink this, and there's my little curve generated over in Rhino. Incredible control. This is the video to look at. Now imagine this is being driven by this editor is coming in as a function, but it's coming in as an expression that's coming out of that node. What you're going to want to do, and we will get here by the end of this incredible, huge tutorial, by the time we get to all the way through here to the very end, because it is about using some openAI in some form, the script editor at the end of evaluate expression will allow us to take that expression, which is right here, and I think it will allow us to put it in. We want to go from x being here, and the y was the solving of the function. I'm not sure if that's going to happen. Oh my goodness, what is that thinking? I'm starting to lose my mind a little bit. I better go back before I crash, and I'm sure I am. Look at this running through and thinking about what I've just asked it to do, but I've had a problem with it. So hang on a second. Solving that is about not having to play with this function editor here. It is coming out as an expression that can be read, and the expression editor wants a text. So in different ways you can go on and you can use those wonderful nodes that we had to import them and then drive the geometries this way into evaluating the expression as opposed to evaluating the function. So that's going to get complex and we're going to go there, but the reason I'm dropping this in here now is because for the visuals of somebody who wants to get in here and start making beautiful curves, go to the params and play solely back around with the function editor. And then slow down, play with the normal, like most common cosine, sine. This is the sine, what's that one called? Cardinalis, sinus cardinalis. I always forget that. I have to think of like a cardinal of Rome or something like that. Anyway, the block functions, the limit functions, these can all be brought in, and you can, while you're editing this one, you can definitely go in. Let me see if that's the right one. You can bring in graphs directly into like this, but you will have trouble possibly referencing those and moving those ones to reference other points within the other graphs. Now they should snap, and they should snap to the graph, and you can start playing around like that as well. But I think it's fun just to play with this function expression and type exactly what you want. Keep things as simple as possible while you solve for these equations. But curves are really what Rhino for me is all about, because curves by beautiful points and beautiful expressions run beautiful surfaces. So let's just leave it at that for now, and then we'll get in pretty hardcore to where is it? Just the very top functions right here, and get you thinking about evaluate function, what it does, evaluate derivatives, and evaluate integrals. Because you may want to do that to solve mathematical problems or physics problems and things like that. But for me, I want to model beautiful shapes because of it. So that's it, and thanks for watching, and we will get farther into the maths function tab.